Hi, today we would want to take a look at exploratory data analysis, also known as EDA in Python. So we are going to have a presentation, and then after the presentation we are going to look into the practical aspect of EDA. The objective of today's lesson is on explaining what EDA is, and then we also want to look into the importance of or the purpose of EDA. And then I'm going to introduce how to implement or the strategies that you can apply and as you work around your data set to do your EDA. In preparation of data analytics or in preparation of machine learning or building your model. To accomplish this, what we're going to do is then we are going to move out from the presentation and we go straight into our Jupyter notebook to practice some of the EDA activities. This session is not going to cover the aspect of feature engineering or how to handle missing data. This will be covered in different sessions that are going to come. Exploratory data analysis can be considered as one of the first stages of machine learning process, and this is a critical process or stage that you want to do before you can start building your model. So when you have done your business understanding, the next thing that you want to do then is, after collecting your data, is to then try to have an understanding, a preview of how the data looks like. And to do that, we are going to apply various techniques, and some of them are graphical in order to quickly have an overview of what the data looks like. It is important for you to do EDA for the purpose of uncovering underlying structures that are hidden in your data. EDA allows you to have an insight or to maximize insight inside your data set. It allows you to then be able to understand and to know the features that are in your data set for the purpose of extracting important features. As we highlighted in our previous lectures, not every feature that we have in a data set will be valuable for answering particular problems that pertain to the solution that need to be provided. EDA will assist us also to detect outliers and anomalies that lie inside our data set. As you will discover as we proceed with future sessions, that outliers might affect the performance of your model as you build in machine learning. We use EDA also to test underlying assumptions that you have as you are given data, and also pertaining to the problems to be solved. EDA also assists us in terms of summarization of the data, whether numerically or graphically. And you will be able to use EDA to distinguish between the types of data types of variables that we have. Let's look into the strategies. This is not a comprehensive, but just a guideline to help you as you proceed with your EDA. So what you would want to do with your when given data set and you have loaded your data set inside your notebook is then to try to examine each variable to see how it is the data is presented in that variable. This is univariate analysis. And when you have done your individual analysis of every variable that we have, you can then move on to do analysis in terms of the relationship between the features that we have. And this is what we call bivariate and multivariate analysis. To start with, you could start by trying to look at the graphical representation of your features, and then you also go on to look at the numerical presentation of it. You will find that when you are why EDA is important is that it makes you understand and have a preview of the data that you have in terms of how big it is, in terms of how complex the data is, in terms of any missing values that you might want to work around before you can feed it into your machine learning model. Because remember, when we are talking about machine learning model, we say that the machine learning model is as good as your data. So if you have the wrong type of data, that means to say the model's performance is going also to be very poor. And now let's look at the strategies that you can apply. And when you are doing graphical EDA, you basically want to look at trying to present your data using different graphs. And if your data is qualitative or categorical in nature, you might want to apply bar chart or pie chart. And if you have got quantitative data or numerical, you want to apply graphs such as histograph, stem leaf, box plot, and the time plot, and so forth. When you're looking at statistical analysis of your data, when you're dealing with qualitative categorical data, you would want to apply or you make use of a contiguous table. And if you are dealing with quantitative or numerical, you might want to look at things such as the mean, median, standard deviation, and the range. When you are dealing with probability models, you might want to deal in terms of qualitative data type. You want to deal with binomial distributions, and when you're dealing with quantitative, you might want to use normal curves. You will also find out that when you are working around with EDA, in terms of the whole process of or the life cycle of machine learning, this is where you would want to put most of your time, around 70% to 80% of your time. You would want to work around ED, try to understand the data, the nature, the underlying patterns, the assumptions that are inside the data, whether you want to add more data or to join. When you want to have a clear overview of how the data looks like, and this will take you through more than 70% to 80%. Well, this we will also put in the factor of doing feature engineering, of which feature engineering aspect we are not going to look into it into this session, but we will look into it in another session or another video to be presented. So now let's move out and look into the practical aspect of it in a Jupyter Notebook. So we are going to go ahead straight on to open our Anaconda prompt. And my assumption is that you have managed to go through how to set up your Anaconda. You've also managed to go through some other previous videos that we have done in terms of the walkthrough in the Jupyter Notebook file. So I'm going to move away from the C into the D drive, change the directory also to my folders. And I'm also going to move away from the base environment into my machine learning environment. So I'm going to activate machine learning environment. And once I've activated my machine learning environment, from there now I'm able to then launch my Jupyter Lab. So it is going to open the current active browser. Okay, so there we go. So we are going to launch our notebook, and we are going to rename that to EDA demo. And we are going to give it a heading, Exploratory Data Analysis. And I'm going to change it from code into Markdown. There we have our heading. So what we are going to do for the purpose of this lecture is that we are going to make use of a healthcare stroke data set that is found on Kaggle. So our dataset from Kaggle, and it is called it's a healthcare stroke dataset. So you can go ahead and check it out and download it. And I'm also going to add a link inside below in the comment section, or where you can get the dataset. So basically, the dataset is about stroke prediction of patients, and it has got different features, and also the target feature, which is the stroke, and it's about trying to predict whether a patient has a probability of experiencing stroke or not. Whilst we working around the aspect of exploratory data analysis, which is our EDA. So exploratory EDA. You might want to ask yourself key questions that will assist you or guide you in terms of working around EDA. So you might want to look into questions such as what is the problem that you are trying to solve? You might also want to look into questions such as what kind of data do we have available, or what type of data do we have? Is it numerical, is it categorical, or something else? What kind? And you might also want to look into questions such as, is there any missing data in our data set? What is missing? And how can I handle the missing data? And you might also want to ask yourself, could there be attributes or features of the dataset that needs to be added, or that needs to be subtracted or removed, or that needs to be altered or changed? And lastly, you might also want to ask yourself how the data is distributed. So these are just simple and basic questions that might assist you in terms of doing your EDA. As you try to answer these questions, you find that it drives you towards doing an exploration of data sets to understand it better. So when you try to answer these questions, you are going to then understand the data set, your data set much better, and then it enables you to clean it up. It enables you to do your feature engineering. It enables you to do your data wrangling until you are in a position where you are comfortable and you feel that your data set is now in a better position for you to build your machine learning model. So let's look into the first stage that we're going to do is to import libraries. We're going to do importation of our libraries and our packages. And so to do that, we are going to make use of libraries. We're going to make use of say import pandas. Import pandas as PD. Pandas is a library that allows us to work around files and manipulate it in tabular forms. We're also going to make use of Matplotlib, Pythonploid as PLT, and we are also going to import Seaborn as SNS, and we might also want to look into Skyline, and as for now, yeah, just leave it. Let's use import missing numbers as an SN, and let's use these libraries for now. We execute the line, the cell, so I'm using shortcut, which is Shift Enter. You can always click on the run when you want to execute the line. And I'm making assumption that you have visited the previous video in terms of a walkthrough in Jupyter Notebook. So once we have got our libraries imported in our kernel, the next thing is then to import our dataset. So we are going to call in a variable dataset assign PD, which is pandas.read CSV, and we are then going to load our dataset. Let me just show you. I've got a dataset that I've downloaded from Kaggle, and I've placed it inside the same folder, my working environment, where we have created our EDA demo. So that allows me then to call in the dataset. Healthcare stroke dot CSV, execute, And then I'm going to check to make sure to verify if we have managed to import well the data set. And at this position, at this moment that we begin to check is it is the stage that we are already beginning to do our EDA, because EDA is all about trying to find an understanding in the structure of our data set. So so we are already beginning to do, and we are going to call in our data set and do a preview, and there we have our data set. As you can see, our data set is, we have managed to upload our data set into our environment, and by so doing, calling in our data set that we have variable there, we are able to view the first 5 records and the last 5 records of our data set. So we are already learning to beginning to understand that these are the columns that we have in the data set, and also just a brief of what each column has. We have got, so our data set is made up of an ID, gender, the age, hypertension, heart disease, ever married, work type, residence type, average glucose level, the BMI, and smoking status, and column stroke. And also from here, we are able also to see the number of columns the number of columns and the number of rows that are also found in our data set. So this is what you would want to do, trying to understand how big the data set is, how complex it is, until you appreciate how and you're comfortable with the type of data that we have available for you to solve the particular problem that has been presented to you in the problem statement by the expert or the domain expert in the field, or the company that you are trying to assist in terms of coming up with the best decisions making use of machine learning algorithms. So we can also view our data set by using dataset.head. And basically .head, what it does is it assists us to also look into only the first 5 rows of our data set as you try to learn and understand it. We can also do dataset.tell. .tell gets us the last 5 records in our data set, again, as we try to understand how a data set looks like. And you can also do the dataset.head, and you can specify the number of rows that you want the head to bring up. So you are running that, you are going to get the first 8 rows in your site for data set. We are also going to look into, we have already seen that from the first view of our data set, it has given us the rows and the columns when we did not specify the head and the tail. We could also want to do what we call make use of a function called shape by calling the data set and then calling shape and execute. Then it gives you back a tuple result whereby you have got 5110 rows and 12 columns. So it helps you to understand how big your data set is. Now we can also make use of a function called function called column, dataset column. You will find that We are fortunate that we are dealing with a small data set, and we are able to see on the screen the 12 columns as they are presented. But in a real world scenario where you are given data set for big organizations, you might find that the data set might have more than columns that can be presented on the screen, and you then want to understand and to know how many columns are there and what are the columns. Suppose there were 24 columns, you then want to know what are the 24 columns, because when it is presented on Jupyter Notebook, if the files or the columns are not fitting, in between it's going to add some dots to show you that there are columns that have not presented. Just the same way, if I'm going to scroll up, we have seen when we called the data set, what it did is it presented the first 5 rows, and then in between, before it presented the last rows, it gives me a row with the dots to indicate to me that there are other rows that have not been presented on the screen. So that's the same way it's going to do in terms of the columns, if the columns are not going to fit on your screen. So for you to understand and to know the columns by their name, you then want to call in the dot columns function. When you execute or run your dot columns functions, it's going to give you the names of the columns that are presented inside your data set. We might also want to go to the extent of understanding the data types that we have in our data set. And to do that, we can do that by the help of a function called .info, the function info, and we have to put those parentheses. And now, when you are here, the .info function helps you to understand the columns, gives you the columns that are available in a data set. It also goes on to give you the total number of columns, the total number of rows presented, and because it understands the number of rows available, it also goes on to show you the missing values in terms of presenting non-value rows that are in the data set. So if you check here for all the columns above, it presents that non-value, meaning to say the rows that have got data, they are 5110, which equals to the number of total entries that we have, meaning to say there's nothing missing in all these data the features, except when we go to a BMI, where we can see the number here does not equal to the number of the total number of entries, meaning to say that there are missing rows inside the feature BMI. And also what it presents to us is the ability for us to see the data type for each variable that we have. If we are going to look at the ID feature there, or the column, we are going to see that it is an integer type, meaning to say it is a numeric. So it helps us to then also answer the questions that we have on top, where we are looking at what type or what kind of data that we have. So you can be able from there to know that you are dealing with a numeric. And when we have something like gender with an object, you know that you are dealing with categorical data in terms of its nature. And this then also assists you to know the libraries that you need to also import into your package as you try to handle and to work around the various different types of data types available. And as you can see there, we have also discovered that we have got this column called BMI that has got missing values, but we can still go on and do a further analysis in terms to understand the missing values by calling our data set, and we call a function called is now. Let's use is now. And then we are going to combine it with sum, where we want it to go and check for all null values that are inside each feature, and it's going to add them up to give us a summary. So if we are going to look at this, we now see the column names there, and just the same we have seen that all other columns, there are no missing values, so we get a sum of 0 in terms of any summing up null values except for the BMI. And now in this at this stage, we are now able to see that there are a total of 201 missing values or records in that column. And once you now understand, as you are answering the question that we have on top of are there any missing values, you then want to determine how you are going to deal with the missing values. In an event that you have got millions of records and you only have 201, you might want it to then assist you in terms of the method that you are going to use in terms of handling the missing data, whether you are going to drop it or whether you are going to try to fill in using various methods that we are going to discuss in a separate video when you are dealing with data wrangling. And it's not part of this, but we are going to do it, and I'm going to give it to you. So now we have an understanding and a view of what is missing in our data set using the numerical presentation. We might also want to look into the bar chart. Whilst we are looking at the missing values. Say missing values, change that to markdown. Okay, so what we're going to do is we're going to call on our missing numbers library, and then we are also going to call in the matrix, and then we put in our data set and we specify the figure size of our chart, let's say 30 by 10, and we execute that to view it. You see, as we try to explore everything that is solid there, it means to say there's nothing that is missing. And when we go to the BMI, we see that it has got some white spaces. Those are the missing data that we have. As it is moving from the first row to the last row, we can see even the position in which we have got missing data. We can also do an Amazon dot var. Let's call in the data set. Okay. So again, we can also visualize, again, it's almost a same presentation where it gives you the total number this time of all the entries that are there, meaning to say that this is from 0 to 1, complete in terms of probability. But when we move to the BMI there, you see that it has got 4909, meaning to say it's instead of having 5110, there is some missing data there. So it helps you to visualize in terms of how much is missing. We are also going to try to understand it in terms of percentages. So let's say that data set dot calling the function that we have already used, dot is now, and then we do a sum of is now, and then we want to divide it by the data set length data set, and whatever result we have, we multiply by 100 to come up with a percentage. Okay, what are we missing? Function object sum. Okay, function object sum, we are missing, we have to add there. Now, when we execute the cell or run the cell, it also computes a percentage of the missing data, and everything else has got 0% because there's nothing missing. However, we now have a clear understanding that the missing data from the feature BMI is around 4%. Let's add more cells. And let's also look at, let's say, describe function. Describe function. Okay, and let's call our dataset dot describe dot t dot describe is a function, right? And the dot describe function gives us a summary of statistical summary of numerical columns. So it focuses on those columns that we have managed to see from using the dot info, which are numeric, which are that is to say the integer and the floats, and tries to give us just a statistical summary of those, where you can get the mean, the standard deviation, the quartiles of the values that are inside our data set. One of the things when you are looking at EDA is you want to answer the question whereby you are looking at what kind of problem we intend to solve. And to answer that is basically we are trying to look at your columns and making use of the domain expert, making use of your understanding during a problem understanding stage, to see what exactly is trying to be solved by the problem given. And then you look into the different variables that we have in your data set, and to see if which column becomes your target variable or answers the problem at hand. And as we have seen that our data set is a healthcare stroke data set, which tries to find out patients who are most likely to experience stroke and who are not most likely to experience stroke. And if looking at that, we'll see that our target variable there becomes the variable stroke. So our target variable there is stroke. That will be a target variable. So in terms of when you now begin to split your data, you want to remove the variable stroke in terms of the testing data set, so that it is not becomes part of your data set. So let's get into an understanding of this particular variable that we have by analyzing it using the univariate analysis technique and methods. So to do that, we are going to make use of cbon, and we are going to call in cbon.countPlot, and we are going to specify our stroke, and then our data set to be used is dataset. So we execute that. We are now able to see or to explore into this data set to see that this is how it is presented. Out of the 5110 records that we have, there we have got the blue column there, which is represented by 0, is the number of people who are most likely not to be affected by stroke. So the 0 represent patients who did not end up with stroke, and while this is the one which is represents clients who ended up being affected by stroke. So we are already beginning to have an understanding, and from here we can see that as we build our model, we already have an understanding that our data set in terms of the target variable is not balanced. So the data set is more balanced towards people or patients who did not experience stroke as compared to patients who had strokes, meaning to say that there are chances that when presented with different variations of people who had stroke, the machine might perform poorly because it would have trained more on non-stroke patients versus stroke patients. We can also do the same on Jupyter, so from the presentation that we had earlier on, we said you would want to then go feature by feature, column by column, doing an analysis to have an understanding of the distribution of data inside each feature. So let's just take another example and do on Jupyter. When we do on Jupyter, this is what we find as the result. As you can see there, I'm going to try to lower down my font a little bit, right? Okay, so that everything fits well on my screen. We can discover that we have got more females in our data set more than male. And we also have another category of gender, which has been classified as other, which then also gives us an insight that we might want to play around the other and find out how best we can deal with the gender classified under other, so that we can have the best results as we work around our model. For us to have a clear understanding of then, say, what's hidden under gender, we can also make use of another function that we have in Python called unique. So what we do is we call in our data set, and then we call in our feature, and then we call unique on that feature. So it goes through again to search only unique values that are in that categorical feature, and it gives us an array that these are the three values that are unique inside this feature, and of course it is a categorical feature. Let's also look at numerical values, and let's call in the matplotlib Python, and call in the histogram, and let's look at dataset heart disease. Let's see what we have. So when we call in, make use of the histogram on the numerical feature, we also see that it has got it's made up of closer to a categorical, because these are completely distinct values where it's either the patient has got a heart disease or the patient does not have a heart disease, where 0 there representing patients that did not have a heart disease, whilst 1 represent patients that had heart disease. We could also make use of Seaborn to plot the same graph. Let's say data set heart disease. And then we are also going to remove the density presentation. Okay, so again from here you can see that clearly we have got the same graph, and it gives us various warnings and error messages that are coming out. In the event that you want to suppress these errors coming up, you might want then to import or say, let's say, suppress them by saying import warnings, and then we are going to say warnings warnings filter warnings, and we are going to ignore. And for seaborne, let's also do what we call seaborne.set. Okay. Warnings.filter. Right, we execute that. So let's go down to right here where we have some warnings. Let's try to run it now. We have managed to suppress the warnings, but we have just ignored the warnings so that it looks neater in terms of our presentation. And what else? So we have been looking at bivariate analysis, at univariate analysis, and we would want to look at bivariate analysis. But maybe before we do that, let's also look at the box plot. Box plot. Let's look at box plot. Let's change that to markdown. Let's just add some more cells. Okay, so we call in our seaborne dot box plot, and we want our data to be dataset, and we are going to focus on one column, and as we are still concentrating on one variable. So let's look at the edge, and we just plot it out to see how it looks like. You will see that that's how the box plot looks like. The box plot tries to give us an understanding where we want to answer questions such as, what is the distribution of the data? Are there any outliers and anomalies that we might find inside the data set? And as we can see that from there, we have got a minimum of almost lying at 0 as being edge. Automatically tells us that there's an anomaly of data where we have a child who is 0 age and also being considered in our data. We are not so sure yet, but it gives us a perspective of trying to understand how the data is distributed. So we have got the minimum. It gives us the lower quarter. It gives us the median, and this. It gives us the 25% quota, the 75%, and also it gives us the maximum values. So it gives you, you are able to understand data from different perspectives. When then you are done with understanding each and every column or each and every feature that we have in your data set. You might want also now to look into various relationships that we have in terms of the features. And if we are going to call in our seaborn and catplot, and we want to understand if there's a relationship between the target variable and gender. So let's say the x axis there to be stroke, and our column to be used to be gender, and what else can we kind of the plot there we want it to be count, and our data is data set. We execute that. Okay, that's how it looks. So it looks much more pretty when we are combining trying to discover relationship between two variables. And you can see that on our far left there, when you're dealing with gender being male, trying to analyze how male patients versus the stroke or the output variable looks like. We see that we have closer to 2,000 male who do not experience stroke versus a small percentage which might be way below 100 or closer to 100 who experience stroke. And also when we look at the female column, we see that the gender, we see that there are more than 2,500 females available who did not experience stroke versus the small number that we have. So this clearly gives you an overview as you try to find the relationship of between of two variables. We could do the same. Let's just copy this again and stroke. Let's use heart disease. Heart disease and see how it looks like. Okay, we can clearly see that when you're looking at patients who did not have any past challenges to their heart, you see that there is most of them who do not experience any heart challenges also did not experience any stroke in any way, just a few number that experience. And as we look at the heart disease component there, we see that those are most likely are closely related and their numbers. It looks small just because when we also looked at the heart, analyze the heart as a column, we find that the number of people who had faced heart disease was also low and small. So perhaps these two could be closely related, but we are making some assumptions which we might also want to then go and visit them to see how they look as we continue to explore and trying to understand the data, or whether we need to add more data inside our data set which has got more information in terms of the heart disease, and see how it's going to change the performance of our model as we build it. Again, we can also do a box plot on two variables. Let's just say dataset dot box plot, and let's say let's do this by edge, and let's say y becomes average. Well, let's just check what was the columns that we have. So let's just say dataset dot columns. Okay, so we have average glucose level. Let's do that, and let's put in stroke. Which what will be our data will be our data set, and let's execute it. Got multiple values of data. Okay, what do we have? What do we need to change there? Let's see if we can just change this. It's not about the issue. Let's go check multiple variables of data. Okay. Let's say by stroke, and let's say age, because we already specified data there. Let's see. Do that. What will be the output box plot? Unexpected Y. Okay, so let's remove seaborne and stroke colon. Again, we don't have the values there. What is the value? Let's do seaborne dot box plot. Okay, let's say by stroke, and let's specify the column to be edge, and then let's say we don't want to show the limit. All right. Okay, so I'm not able to get the results there as we try to do the box plot. Let's just remove it and look at the multivariate analysis. Let's look at the multivariate analysis rather. Analysis. Okay. And some few rows, and let's call in the seaborne dot plot, and let's specify our age. And let's specify our Y as Let's use again, let's try average glucose. And target stroke, and give it a pass it our data set. Okay. All right, let's remove the lines. Big range is equals to false. Okay, so when we now run the multivariate analysis, we are clearly able to see that in terms of the age and the average glucose there as presented, and the color codes being 0, the blue ones being non-stroke, and the gold there being the stroke. We can see that when the age is below 40, we have got less patients are likely to experience stroke challenges, and even when they are the small ages there below 40, their glucose level also is below 100, concentrated below 100, but as we go above 40 years to 80, we can see that the number of stroke is more concentrated along those ranges. So this is how you would want to see the relationship of two or more variables concentrated together against your target variable there. And one also key tool that you might want to use when you're dealing with multivariate analysis is to make use of the heat map. But you will find that okay, let's just look into it. Heat map. Okay, that's the heat map. So for us to work around the heat map, what we're going to do is we are going to drop some columns which are non-numeric, the categorical columns. But you'll find that in the real world, what you want to do is when you're faced with categorical, you need to clean them first. You need to encode them using various techniques such as one-hot encoding, label encoding, and then you create your heat map. But for this session, we are not going to look into the aspect of one-hot encoding of categorical or changing the categorical data. We are going to do it in a separate session. So for us to demonstrate to the aspect of heat map, we're going to drop the categorical variables that we have. So what we are going to do is we are going to call in matplot dot figure, and we want our figure to be your figure size 12 by 7, and then we are going to call in our seaborne heat map, and we are going to call in our data set. And as we call it, we are also going to call in a method called drop, which we are going to pass in some categorical or features that we need to drop. So let me just go up there again and do dataset columns, and we want to drop even the ID doesn't make any value, it's just a number. We are also going to drop gender. We are also going to drop ever married, and work type. Let's just drop that so that we remain with the numerical columns. Residential type, and what else? Smoking. So whilst we are dropping, take note that we are not saying that these are less important as far as trying to detect whether a person is likely to have stroke or not. But rather what we are doing here is we are just removing the categorical data which we needed to change or to transform so that it becomes numeric. Remember that machine learning likes and loves numerical data. So you would want to then convert it into numerical and then do your heat map. So for the purpose of demonstrating, we are going to just drop it and then present our heat map. Okay, we have another challenge. Not found in axis. Okay, what have we missed there? Let's see if I'm going to do something like this. Trying to see if it's going to give me the help functionality of what I'm supposed to put. So heat map, I need to put in my data set, data, and also then let's check if we have an example. So what I'm going to do is I'm just going to comment out my information, come down there and check to see if it is I have an symbol. Okay, unfortunately it doesn't give me an example of the layout. So let's see, heat map data, minimum, maximum. Okay, let me just put that back. Okay, let's add minimum value to become -1, our maximum to become 1. What else? These are supposed to be outside. Invalid syntax. Drop specifies labels from rows and column. So what we need to do there is we have got our not found in axis. Okay, so we are trying to drop, we have to specify the axis is equals to 1. Okay, and the drop axis is equals to 1. Then we want to do a correlation. Okay, let's see what we have. Okay, yeah, we now have a result, and let's see if we can change that to around 10, maybe about 5, make it a little bit smaller. Okay, so it's now fitting on our chart. So from here we can see that the heat map, what tries to present to us is in terms of relationship of variables, trying to look into their positive and negative relationship, and according to our map there, whatever is more light is more positive, going downwards. So let's add some more variables there. Let's say v min is to -1, max is equals to 1. Okay, and correlation, let's say CMAP let's say annotate. Okay, now we have a more clear and more understandable heat map with a range of from -1 to +1. And we can clearly see that where we have a +1, the darker color there means they are more positive, and you see it's more darker when it is a variable against itself. And so we want to look at darker colors. Those are, I would say that age and BMI, they are more correlated in a positive way. So that's what you will be doing and looking around to see the relationship of variables inside the data set, so that you know which variables you need to select when you are doing your feature engineering. One way of understanding and exploring your data is to make use of what I term a cheat sheet. Tell it cheat plot methods as we wind up. So to do that, I'm going to call in a seaborn. We have already seen some of these individual images before, but this is how you can do it when you want a quick understanding and overview of what is available, data set. And then we are targeting our target variable, say stroke. Okay, so this is a heavy computation depending on how big your data set is, and also the computational power of your machine. It might take some time. So if your machine is of a lesser computation capacity, you then want not to run this this code, because it's going to take a lot of time and is going to be very heavy on resources. So what it does, it tries to compute all the graphs, especially the numerical ones, as it tries to find some combinations, in which then from there you can pick the one that interests you the most, and then you can view them quickly using bivariate analysis. And another one that you can also use is to do the distribution, and you can just say dataset dot list, and let's say our figure size there to be, let's start with a small one, and 5, and then we want to plot. See, again, it's going to be a little bit heavier. Okay, that's what we have. Let's try to increase it to maybe 20 by, say 20 by 10. Okay, so we are able to see a histogram on all the features that we have there, which are and then you can able to see their distribution, and from there you can make sense out of it, and then it helps you when we are moving towards feature engineering. So this is it, just an overview of helping you to understand what EDA is about. And just wrapping up, what you would want to do is to make use of key questions such as trying to answer the question, what is the problem to be solved? This guides you towards the target variables and towards trying to make a relationship between the features and the target variable. Try to answer the question, what kind of data do we have? Helps you to then want to look into the data types of each feature that we have, whether it is of categorical, numerical in nature, or so forth. You would also want to ask yourself if there are any missing values or data inside the data set. Helps you to then work around methods that you need to input your data. You might also ask yourself questions such as, are there any features or columns that need to be added inside your data, or that need to be removed, or that need to be changed? Okay, that needs to be changed. And you might also want to look into how the data is distributed. This helps you to do a thorough exploratory data analysis in a data set as you move towards data wrangling and feature engineering. Once you are done, you then want to shut down your kernel. And once it's stopped, then you will see that even your Anaconda will also stop, and you can always exit your Anaconda. So we are going to look into data wrangling, feature engineering in the next session. So kindly subscribe if this video has added value and you are of interest of it. Kindly subscribe to this channel so that you won't miss the next upload. Also remember to like and to comment down below there. If there are any other techniques in terms of machine learning model or building of machine learning that you would want me to cover in the next sessions, please kindly comment in the comment section below. Bye.